Forbes put out an article a couple of years ago that said that AI companies require 3 to 6 times the amount of investment as traditional Saas companies, but in return offer a 3 to 6 times larger market opportunity. Paul Graham recently tweeted that the biggest trend that he's seeing in startups is AI, and while AGI, that sort of artificial general intelligence, might be still quite far away, for narrow use cases, machine learning can have significant impacts to make different applications incrementally better. Paul Graham also said that data seems to be the limiting factor, rather than model building techniques or computational resources. And generally what he's seeing is if you have the app, then you tend to have data as well. We at Particular Audience strongly agree that data IP is the future of any consumer or business software as a service applications. We believe that data IP needs to be unique, it needs to be scant, it needs to be rare, it needs to be hard to obtain, and that data IP is something that can present significant defensibility and scalability. Well, Andrew Ng launched the campaign for data-centric AI. Andrew Ng was the founder of Google Brain, he was chief scientist at Baidu. He was founder of Coursera, which he also famously ran a bunch of extremely famous AI and data science courses on. He believes that data is central to the future of AI and machine learning, not just the model development. In fact, the models for many applications are sort of a solved problem. They were written as long ago as the 70s in some cases by academics, and it's more about making them performant in real-time computational environments, making them performant for seamless customer experiences, and it's actually getting them that clean and large data sets to make them function today. And that is the sort of exciting inflection point that we've been at for the past few years, and we're seeing continue to grow, especially with sort of vectorized approaches to models that are even more computationally efficient than previous statistical approaches to prediction online. Martin Casado, Andreessen Horowitz had said that proprietary data is only defensible when it is extremely scant, rare, or the data sources are reticent to actually give it to many people. I think this is especially true of internet filtering technologies or information filtering technologies on the internet. In theory, anybody can scrape the web, anybody can build knowledge graphs made up of natural language processing, computer vision, even backlinks to try and develop an understanding of the web and the information on that web and organizing that information for people. I think where we see the most opportunity is in collaborative information, or collaborative data. Collaborative data is something that you cannot scrape, something that you have to have proprietary to your application, whether that be a web browser, or a really good example of collaborative data and data network effects in action would be companies like Waze, which Google acquired, and Google Maps, and that sort of real-time information about where there's a speed camera and real-time information about where enough phones are slowing down to indicate that there's a traffic jam and that your route can be redirected elsewhere. That is an example of a real-time data network effect with proprietary data based on the user corpus of those applications. Samir Singh, who is probably one of the best commentators on the mechanics of network effects that I've found on the web. He has a blog, breadcrumbs.vc. He talks a lot about different types of network effects and especially data network effects. And I think it's really a measure of how effective a data network effect really is by how fresh the data is. Does it have a fast decay rate? If the data can last for a very long time and still be relevant, it's probably less defensible. And what you want is you want high defensibility and high scalability. So if we go back to Waze as an example, that real-time traffic information isn't much use to anybody 2 weeks from now. And that is an example of the data network effect being successful. Samir actually said something extremely interesting to me. He said that the challenge a lot of people have in understanding layering is that their understanding of network effects is iffy in the first place. The network effect exists at the level of the interaction, not the product or company. Once people understand that, the idea of layering tends to be more accessible. And that was really based around a conversation or a question I had about layering network effects within businesses and starting to understand how different combinations of network effects can work. And I think it's especially interesting when we think about data network effects. I think when you think of a social network effect, the interaction, the connection, the message is something that we can all really understand. From a data network effect, when you're looking at a wisdom of the crowd or a sort of mass corpus of users contributing collaborative data, you're dealing with a great many interactions, and you're understanding what future interactions can actually do for a sort of 10x user experience for those future users. And this is really how we see us starting to build a more advanced understanding of the information on the web, and how to filter automatically before people have to search for this stuff in the future. Before you have to ask for the information, we want to be the business that's providing that information to you. So the Forbes article that mentioned that AI SaaS and AI companies versus traditional SaaS require about 3 to 6 times more investment up front. Why is that the case? You know, I might speak to a workflow management SaaS company, and I might speak to a HR management platform SaaS company, and they might have exceptionally high gross margins, arguably be in a less defensible space, perhaps depending on that system of record as their core tenet of defensibility. And I might find out from them that their cloud costs are, let's say, $10,000 a month. Your typical AI machine learning equivalent might be spending $100,000 a month. And there are likely to be a lot of fixed costs in that don't necessarily, the fixed costs don't necessarily scale as the revenue and the user base scales, but there is that underlying infrastructure of data pipelines and GPU compute capacity and extreme scale of data that comes through how we process, how we clean, how we might have to report, how we might be using that data to train models. Obviously, however much you want to scale, the amount of data that you're using to train the models gets more and more expensive. It requires a lot more R&D early on and throughout the life cycle of that company. And generally what you will see in a SaaS company is that it might grow over time, but then the rate of growth might slow as it starts to plateau. Whereas when you're looking at, say, a deep tech company, you're likely to see steps in progress. And those progress leaps could be related to technical breakthroughs, technical innovations, reduction in compute, or reduction in cost of delivering the technology, or commercial advancements such as user numbers, or use cases, or actual revenue. So where we see the exciting thing is that you're going to get some hybrid of that sort of initial product application that might plateau over time, with the steps and advancements that are worth investing in up front, because that's ultimately going to correspond to the plateauing initial SaaS model with the late stage hockey stick. And it really is that hybrid approach that we're extremely excited about a particular audience, where we have both the benefits of a SaaS company being high margin, high growth, highly defensible, low churn, high net revenue retention, but also with the future potential of that hockey stick, which is that through the technologies that we develop and the proprietary data sources that we are generating, should present and are already presenting many applications for other applications and products that we're able to take to market.